Alright, back to 100 Days of now. It's day 66. I'm up early today, so let's try to get this done early as well. ML project, part 20, prototype, analyzing pre-processed data, figuring out what the model is actually doing and how to build, and decide how to build the deep learning model. Okay, let's use this. Open up the Docker container and get things started. Okay, let's see. Where did I leave off? So I implemented the embedding layer on top of the text vectorization. I have a flatten and dense layer. So I think I'm gonna remove the flatten and dense layer. That way I can observe like what is going on after the embedding. I'm gonna run this and then try to get analysis on the produced data. So pretty much like the steps so far are like pre-processing steps. So let's see. We have shape of 15,000. Couple of values. 1, 2, 3, up to something. The shape, I don't know, doesn't seem regular. Let's print out like test like 0. Why is it in? Okay, so this prediction is now being saved. Text n. So let's do process. There we go. Okay, so the shape is 15,000 by 4 by 32. So this is the number of rows. This should be the number of okay, how do I visualize this? This is the number of rows. In each row there's 4 arrays, and in each one of those 4 arrays there's 32 values. 1, 2, 3, 4, 5, 10, 15, 20, 30, 31, 32. Okay, there we go. So what do these values represent? I guess that is one of the questions that I have. So we went from one row containing one like paragraph to now it contains 4 arrays of 32 values each. So what is happening here? The dimension as a size as a vocabulary. Let's see, that's set to the same thing as the text vectorization. So text vectorization at the end will end up outputting an array of 15,000 values with 4 in each row, in each one of those 15,000 rows. And that gets fed into the embeddings layer, where another 32 values is extracted from each one of those rows. Alright, so we see this 4 and 20. So that 4 gets converted into 0.25 and 0.1. That 20 gets converted into 0.6 and negative 0.02. So then what's happening? Visualize this once again without the vectorized layer. Without the embedding layer. So this 10, 64, 411, and 11 gets converted into those sequence of numbers we just saw. The question is, why is it only 4? Like here, and so output sequence length is set to 4, but why? It's time dimension padded. So batch size is 15,000 here, and output sequence length is 4. Sequence length to pad outputs 10. This converts the input into the right format to pass into the vector layer. So let's check out his data set right here. It contains like three things: foo, bar, and baz. 1, 2, 3, and then 1, 2. So these two input data get converted into this and this. So if I'm only putting 4 down, is my vocab getting like truncated? Because okay, for his example, it's perfect. There's 3 and then there's only two words. But for me, I have like a lot more words in each paragraph. So it's a string array that contains several different strings. And I will count how many words there are approximately. So I can use that for the max length. Let me check my code. I think I've done something similar. I use tokenizer instead of text vectorizer. Initiates text vectorization by passing a list of vocabulary terms to layers init method. What is the max length? Oh, I should apply this. Did I end up applying it? Nope, I didn't, so I should apply that. what is it called? Standardize? Why isn't there an amplifier standardize here? Oh, dude, I was looking for embeddings. I'm gonna use the same. Oh, this is default, so I don't even have to apply it. What if I remove this, right? And now I run the model, what happens? So the dimensions don't match up. Hmm. So it's put on white space by default, so I'll let on white space. This is what I need to learn. Creates a vocabulary for you based on the recombined tokens. For this reason, you can specify a max token integer, maximum size of the vocabulary for this layer. To build this index, you'll need to call the layers a depth method to fit the state of pre-processing layer to the dataset. Can't see here. Max tokens is 5. He hasn't really set the output sequence length. So it defaults to 5. 1, 2, 3. Yeah. Vocabulary has 3 words. Prediction data has 1, 2, 3, 4, 5. Okay, yes, yeah. So 4 here assumes that we only have 4 words in our entire string. That's not good. We need to figure out on average how many words are there in each paragraph. So that would be the next step. I mean, for a simple way, I mean, I think I was getting around like what, 37, 32,000, 33,000. What I could do is just set it to that. Just set it to 33 for now. I mean, I don't really want to go through and calculate the average of how many words there are in each string. Probably a good idea to do it, but kind of getting lazy now. So let's check now how this works. Sick. So each one has 33,000. Now let's add this embedding layer. So it's gonna have in 15,000 rows. Each row has 33,000 items. Well, in this case, it becomes an array, and each of those arrays have 32 elements. It's another array of 32 elements. So embeddings gives you more information. It just encodes like a value for each word, I think, in relative to this sentence. So it gives you some sort of to extract information from the data. It's taken a while, actually. Oh, totally lagged out. What the heck happened? What is going on? This is not working. Just completely like restarted my kernel. Okay, Might be the reason because I'm streaming while doing this, and it seems to be having a hard time training. Might be the reason because this vector becomes freaking huge. What I could do is add a flatten layer here. Yeah, embeddings there and see how this is doing. My God. I think it ends up being a bunch of zeros, actually. Don't even think we need a size of 33,000. How do I display this entire array? I want to count the number of zeros. That's a lot of... Is that zeros or non-zeros? That's a lot of zeros, man. 491 million. What? So literally, I only need the max length to be around, because it's giving me 32,799 zeros. 201. So I could literally just change this. Let's check the values. 92. Okay, let's not do this. Let's put it into pandas and then display a graph out of it. Otherwise, this is just annoying. Let's see. Let's yeah, if you go to, yeah, I can put this in data analysis. So is equal to plus x. Now what is it? Modify to data. There are no column headers. I can see here it's a sparse matrix, so let's get the summary of data. Summary statistics. Doesn't really matter, but wait, mean, median, describe, I need describe. Oh, I need. I could describe the entire data set, and then yes, okay, so processed XDF. Describe. Let's let that run. In row. I'm just having a hard time to run. Right, it calculates it for each column. That's why this is useless. Instead of describe, I need to check how many values are at 0 in each row. Let's do this. So we get this, and I want to get the mean of this. Let's put non-zero is equal to this. And non-zero is dot mean. So I do 27. Let's go back here. Instead of 33,000, we can change it to around 250. Now let's see how things do. It's okay, we still have a lot of zeros. Mean decrease to 170. I don't understand. I mean, is it like that? Like if I decrease the max sequence length, some words get padded. Now the mean is 174. It used to be 230 or something. How about if I change it to 200? What happens? It also decreases again, but it's more condensed. There's not that many zeros in the first one. So let's keep this. This looks like a pretty good filled array. So let's add embedding layer. Why can I not do this? Let's pass 2D input. What I could do is add a flatten layer. Awesome. This gets mapped to 64, and all of them are non-zeros. And there are some significance of what each word represents. So now I can move on to the actual model. Oh wow, I did not know it's taking that long. So I'm going to wrap things up for today and continue this tomorrow. Boom. So I'm going to figure out how to build the deep learning model tomorrow. Build it and run some tests. And that's the plan for tomorrow. That's pretty much it for today. I'll be back tomorrow.